catch a fly.
And of course, I'm back scheduled an event in California for Mother's Day.
Oh.
My daughter is not a happy camper.
Grab a chair anywhere.
Morning.
Give me a chance to warm up the engine.
Come on in.
There we go. Well, thanks everybody. This is the third session of our little mini clinic talking about introduction to aerobatic maneuvers. We didn't have last week. It was a little cold and windy, so thanks for everybody showing up today. We're going to talk about some of the final maneuvers and then apply some demos and kind of review some of the things that we talked about before. So today we wanted to talk about the aileron roll. Actually a shark's tooth, which we've kind of done before. It's very similar to the half reverse Cuban. The spins, which are controversial to say the least, even in judging contests. So we'll try to tell you what we think a spin is and how you initiate it, and what the judges hopefully think the same, so we'll go from there. Let's start out with the aileron roll. Give me just a second here.
Fly that thing and shut it up.
Aileron roll actually appears to be a fairly simple maneuver. We're just coming across the box, we do one tail roll and keep on flying. Well, there's actually a lot going on there. And you'll see some of the flyers, especially in some of the basic classes, will start with the roll. And if you just do the roll, something like that often happens. So you'll often see them come in, tilt up just a little bit before they start the roll, and then fall. And by the time they fall, they're level again. So it's a question of, do I lose some points by coming off axis? And if you remember, we talked about judging points in that if it goes off 5 degrees, it's a half a point. If it goes off 10 degrees, it's 1 point, and 20 degrees is 2 points. So you just pass this around to kind of get an idea of what that might look like. So if I'm coming in trying to do the roll, and I bump it up maybe 10 degrees and do my roll, even before I start, I just lost at least a point. So how do you do that roll? People do it in a couple of different ways. Some people like to come in and do it real quick, so you can't see it fall. But that makes it kind of hard to stop, because the faster you're rotating, the harder it is to stop at level. And again, if the range of tilt is 5 degrees, half a point, 10 degrees, point, 20 degrees, 2 points, it comes up very quickly. So if you're spinning quickly, yes, you may not fall, but the problem is you're going to be able, where do I stop it? That's difficult to do. So it's better to do a little slower. As we talked about, if we do a little slower, then I go, oh, I fell. Well, what do you have to do? You can do it 2 ways, or maybe even a combination of those. Some people will take, about the time we get up that upside down, push the elevator a little bit down, so we kind of tickle the nose up a little bit to maintain that level flight, and let go of the elevator as we come through again. So then you can do that roll, little elevator up, off the elevator, and back through again. Other people like to use the rudder, and I guess I'm kind of that persuasion. If we come into the roll, about the time I get to this point, I start kicking in a little right rudder, then out of the right rudder, then into the left rudder, and out of the left rudder. So as I'm coming in knife edge, then I've got that rudder which kind of wants to pull me up, but not so much that it pulls me up, it just keeps me from falling down. And that's just a question of feel, much like putting in the elevator at this point in time. You just play with it and practice with it and get to a point where it feels like you've got control over it, and you've got a speed of the roll which is controllable, it's nice and smooth, either bumping the elevator or bumping the elevator, or the rudder. And John will probably show you how that works both ways and how it looks when it goes wrong. So again, in the demo, we'll show you how we're supposed to do it, and we'll show you the common errors of what it looks like if you miss it.
There's no preferred.
No, I think it's personal preference, isn't it, for you?
It really is. As you get more and more practiced, you will start just flying everything and not even thinking about it.
Well, there's
You'll
another
be flying
timing
elevator
question with all of it. I mean, even with the elevator, it's a real timing question.
It's a real timing
It's
question.
time.
And when you see the guys execute a real slow roll, rudder,
That'd be rough.
out of the rudder, into the elevator, out of the elevator, into the rudder, level out again. And the guys that have done this a long time, you'll see them fly the entire field. Maybe a quarter of a mile.
Down.
Full scale!
He's pretty low.
Go down, guys. We don't know.
Wow. It's all black. Was that military?
Probably.
So when you see the good pilots who really can do that all the way across,
they're
they'll just hold that
flies.
heading, they'll hold that elevation, they'll hold that pitch. It looks really, really pretty, and that just comes
It's
from a lot of
pretty
practice.
now, yeah.
Shark's tooth. We talk about a shark's tooth. Before we executed the half reverse Cuban, pull to the 45, half roll, pull the loop, and back to level again. And remember, every aerobatic maneuver starts at level flight and ends at level flight. We may be upright, we may be inverted, we may be high, or we may be low, but every maneuver starts level and ends level. So on the reverse shark, we pull here, on the reverse half Cuban, half roll, pull the loop, and back to level. A shark's tooth is much like it sounds, it's a point as it's drawn. It looks like the point of a tooth. We call that a shark's tooth. So to fly that in a reverse shark's tooth, we would fly up at 45, do the half roll, pull down. Instead of pulling a loop, when we pull over, we'll pull to a vertical. We draw a straight line down and then over. So if you take a look at that figure, it's up to a point, down to a vertical, and back to level flight. So very similar to the half reverse Cuban or the half Cuban, but instead of pulling the loop after we get to the altitude or when we go into the altitude, we're pulling to a vertical line or we're dropping to a vertical line. And again, John will show you how that looks, both right and wrong. Spins. Spins are difficult because they have to start with a stall. And what is a stall? There are many definitions of that, but there's really only one definition when you read the rule book. And I think it's a little different in pattern than it is in IMAC. In pattern, the rule says we're coming across high, and we pull back on the throttle, we start feeding in some elevator, so the plane no longer flies. And what does that mean when it no longer flies? Well, it means there's no longer lift. So what happens when there's no longer lift? The plane drops. So the start of a spin is a stall. We're flying across, we're adding some elevator, the plane's slowing down, we're basically idle, and at some point in time the plane's going to stop flying. In IMAC, the definition of a stall is when the nose and a wing drops at the same time. In pattern, they're saying the nose has to drop. So a little bit of definition depending on what you're flying. So in IMAC, I'm flying along, I'm stalling, the wing and the nose drop at the same time. That's why I spin. In pattern, we're flying along, the stalls, the nose drops, and then the wing spins. So depending on which one you're flying, which type of airplane you're flying, it's different. I don't really know why the difference is, other than the fact that, in IMAC planes, they are scale representations of a large plane, full scale. So perhaps it's just that characteristic in full scale that stall that particular way. In pattern, these are very specifically designed planes for precision flying. So they're actually better flying airplanes from that standpoint. So maybe their stall pattern is more predictable. But either way, we'll show you what it looks like when you enter into a stall and when you don't enter into a stall, and what the common errors are. Some of the common errors are, they talk about a wing over. I'm coming in, I'm trying to stall, it's not stalling. Oh, what am I going to do? What am I going to do? I hit the ailerons and roll into a stall. As you'll notice, when I hit those ailerons, did the nose drop? Did the wing drop? Well, the wing dropped because I hit the ailerons, but I wasn't in the stall position. I was just in an aileron roll. So I didn't come to a stall, I didn't drop because I lost flight. I came in, I'm still flying, and I just roll the ailerons. And that's more like a barrel roll that you see on Baa Black Sheep when they're rolling over the Corsair, they're dropping altitude. Another one. And we'll take a look at that. Well, that's part of the spin. To get into a spin, we have to start with the stall. And once we get into the stall, we talk about kind of sticks to the corners. And we'll show you kind of what that means. We kick in some rudder, kick in some ailerons. So when we start to stall, and if I'm starting to lean this way, I'll kick in left rudder and hit the ailerons so that I'm spinning down. And I'm spinning in what we call auto rotation. If I come to a stall and I let it stall like this and I just do an aileron on the way down, that's not a spin. So take a look at that again. I came to a stall, I just dropped the nose, I'm going vertical and I spin. That is not spin. That is an aileron roll in a vertical plane. A spin is when the airplane goes into an auto rotation, and that you'll see the tail move and you'll see the nose move. If you take a look at that when it's spinning, it's like an hourglass. Something happened. If you look at the parameters of the airplane when it's spinning, it looks like this all the way around. And if you take a look at it, it's like an hourglass. If you look at the plane of the line of the plane. So when I'm in auto rotation, I'm spinning like this. and then down.
Like a flat
I'm not
spin.
spinning like this and then down. That's a very distinct difference. This is a 0. This is a good spin. Now when you see some of the 3D guys, like if you've seen Spencer do some of his aerobatic routines, he goes into something called a flat spin. He'll come into a stall and he'll spin up here like this, and he may spin 20 or 30 times before he really loses altitude. That is a spin. It's a very high power spin. And he's basically using his motor to keep him, an elevator to keep him suspended. What we're trying to do, we're coming into a stall, we're basically at 0 throttle. We come into a stall, we go into a spin at 0 throttle, whether we're doing 1 spin, 1.5 spin, 2 spins, whatever's required, and then we prepare to try to come out by releasing controls so we can get the proper orientation. If I'm coming in and doing 2 spins, there's 1, there's 2, and there's my vertical plane. Once I finish the spin, I'm typically finishing the spin something like that. And a good spin, you'll see the pilot drop the nose down to vertical line, and then continue and draw that vertical line after he completes the spin before he hits the ground. So those are the kind of requirements of a spin. We gotta have a stall, we've gotta have auto rotation, and when we finish, we've gotta point the nose down, draw a vertical line, and then pull out the level flight. Enter level flight, exit level flight. Pretty simple, right?
Sure.
That one's tough.
When you hit the dirt.
That is probably the